Okay, in the numerator there at the top, right? This is sine squared, it's given as sine squared. Do we all agree that this is in the third quadrant where sine is negative? So this should become negative sine x squared, right? In which case the negative becomes a positive. So all fine with that. These are two separate cos ratios. All right, the first cos ratio is negative, the second one is positive. So this is a cos squared from the start. So we can't now say, okay, if I multiply these together, it's going to become cos squared, so I can disregard the minus. Okay, so we understand the difference between the two scenarios. This one was a sine squared from the start. That's why it becomes positive. These are two separate cos x's. All right, so what happens here was this minus and that minus, if you multiply them together, will become a plus. Okay. What's that make sense?
Not ever matter whether it's minus or plus. Just go straight ahead. Okay. Or we have to write the minus in the bracket anyway.
Okay, can we move on to number 4? Number four. Okay, that's what I got for number 4. 1 over 1 plus sine x. Alright guys, you can see there negative x is in the fourth quadrant and sine is negative in the fourth quadrant. So this plus sine negative x will become plus negative sine x. Alright, so I just changed the plus to a minus from the start there. Sine is negative in the fourth quadrant, so it has to become minus. Here again, I didn't even bother to work out what quadrant that is in because of the cos squared, it's going to become positive cos squared. Alright, so don't waste time on that, guys. If you see that it's cos squared, or sine squared, or tan squared, it's going to become positive anyway. Alright, so just change it to positive cos squared x from the start. Now, I mean, I suppose you could think that you're done here, but this is still a bit, there's a lot going on, right? And they might also say that you have to write it in terms of a single trig ratio. So we can't leave it with a sine x and a cos squared x. Okay, so cos squared x, do we agree with this? 1 minus sine squared x. And then we should notice, okay, these kind of look similar. This is a difference of 2 squared. If I factorize this as a difference of 2 squared, we're going to get 1 plus sine x, 1 minus sine. Right? Then I can cancel those out and I will be left with 1 over 1 plus sine. Any questions on that one? I will post these answers with the announcement later on. So if you are missing some of it, you can get it there. Yeah. Have they not? Okay, I'll just follow that up. Sorry, we were talking about it yesterday. I don't know anything. Okay, number 5 was a bit more complicated. There was more stuff to do. All right, maybe you did your steps slightly differently, but the answer was tan x. Yes, did anyone else get tan x as the answer for this one? Yes, okay. See a few nods. Guys, the first thing there is that you have x minus 180. So x is in the first quadrant, then you minus 180, you'll end up in quadrant 3. Okay? What is tan in the third quadrant? Positive. So that becomes positive tan. There you have a mark already, guys. All right, just for doing that, 1 mark. Then we have a plus. So now we need to realize that these are 2 separate terms, guys. So we won't just be able to cancel stuff out, something at the top and at the bottom, because we actually have 2 terms in the numerator. Okay, that makes this question a bit more difficult. 180 plus x, quadrant 3, sine is negative. Negative x, quadrant 4, cos is positive. Here at the bottom, this is quadrant 4, but it doesn't actually matter because it's sine squared, so it's just going to become sine squared x. Okay, just for doing that, guys, you already have 4 marks. Okay, even if you don't know how to go further, 4 marks in the back. Now, what I did here was I just made that plus minus just a minus. All right, I don't like having 2 signs next to each other like that. And I realized that if I want to simplify this a bit, then I'm going to have to also change that tan to a sine over cos. All right, For doing that, you also probably get a mark, so that's 5 marks. Then, now we have a compound fraction, right? And what do we do when we have a compound fraction? We multiply the top and the bottom by the denominator, all right? Or the LCD if we had multiple ones. We only have one here, so we're going to multiply the top by cos x and the bottom by cos x, and then that is what we get. We have 2 terms here, guys, so we have to multiply cos x by the first term, which is just going to give us sin x, and by the second term, which is where that cos squared x comes from. At the bottom, I only have 1 term, so I'm just going to write it next to it. Yes. Yes, yes, that's fine. Yes, yeah. Okay, then what I did from there was I took sin x out as a common factor, and I was left with 1 minus cos squared x. I still had the same thing here at the bottom, and then I noticed, okay, I have 1 minus cos squared x, which is actually sin squared x. All right, so I changed it there, that's what I did. And then I actually had a sin squared x and a sin squared x, so one at the top, one at the bottom, so I could cancel them out. And now I was just left with sin x over cos x, and that is tan. Okay, but like Fayaz was also saying now, you could have done it differently, all right? It doesn't matter if your steps are different from mine. It's fine. What does have to be the same, guys, is this first line or second line, it depends on how you think about it. All right, this first line, you need to have these 4 things shown. That has to be the same. Then you're probably going to have to change tan to sine over cos. All right, and then obviously your final answer has to be the same. But the stuff in between, there would have been different ways in which you could have done it. Okay, did you guys get as far as exercise 13? Yeah. Right, let me just see here. At some point, you have to do 3 and 4, hey? Yeah. I might have to just write them out now. Any questions on this, guys? Are we fine? Okay, I'm going to do those 2 from exercise 13 with you quickly. Sorry, I just kind of assumed that I had them in my file from previous years, but clearly my assumption was wrong. Page 153. Okay, number 3. Why does this kind of look like the example that we did yesterday? Isn't it? Let me check, it might be sine. No, it's not. Oh, it's very similar, but it's not the same. Okay, tan 135, tan 120 over sine 150 sine 210 cos 330. All right, and obviously it said without using a calculator, so we know we're going to have to use reduction formula. We're going to have to get them to the what's it called, special angles. All right, so I'm going to skip that middle step, guys. I'm not going to write it as 180 plus. I'm just going to do it here at the top, if that's fine. Sorry, I'm just trying to save some time. So 240 is 180 plus 60, right? Which quadrant is that in? Quadrant 3. What is sign in the third quadrant? Negative. So this is going to become negative sine 60. That first one. Okay, 135 is 180 minus 45. Right? What is 180 minus? Which quadrant is that? Quadrant 2. And tan in the second quadrant is negative. So negative tan 45. 120 is 180 minus 60. 180 minus is in the second quadrant. What is tan again in the second quadrant? Negative. So that's going to be negative tan 60. Over. Now I don't have enough space to do it for these bottom ones. So you must just listen up. 150 is 180 minus 30. Second quadrant, what is sign in the second quadrant? Positive. So that's going to become positive sine 30. 210, 180 plus 30. 180 plus is quadrant 3. What is sign in the third quadrant? Negative. So negative sine 30. 330, that is, I'll write that one in. 360 minus 30. Fourth quadrant, what is cos in the fourth quadrant? Positive. So this is positive cos 30. Okay, guys, do we notice that we have 4 negatives? What is that going to become? Positive. Hey, because a negative times a negative is a positive. So those 2 minuses are going to go away. And then I'm left with a negative divided by a negative, which also is a positive. You have to show all of those minuses, like I said yesterday, in your first line. You have to show that those negatives are there, even if they're all going to cancel out. Okay, because if the minuses aren't there, I'm going to have to assume that you think that all those ratios are positive in all of those quadrants. Okay, so you have to show me that you know that they're negative. Okay, now we need our triangles, which I hope you know off by heart by now. If not, you're definitely going to have to know them for Monday. Sorry, my pen is smudging all over the place. Okay, now we must, okay, it's off screen, but you get the idea. All right, now we must find all of those values. So sine 60, sine is opposite of hypotenuse. So that's root 3 over 2. Then we're finding tan 45. Sorry, I just said tan. That's not great. Tan 45. And tan is opposite of adjacent. Hey, so that's just going to be 1. Now, guys, please, I know it seems silly, but just write it there just in case so that I can see that you know that tan 45 is 1. I don't know if you will lose a mark, but you might. Okay, so just play it safe and rather write it down. Tan 60, opposite over adjacent. So root 3 over 1. So I'm just going to write root 3. Suppose it's overkill with dots and brackets. You can choose either. You don't have to do both. All right, and that is then all over sine 30, which is a half, and another sine 30, which is again a half, and then cos 30 adjacent over hypotenuse, that's root 3 over 2. Now, guys, just as an aside, because we are going to talk about it later today, do we notice that the values for sine 60 and cos 30 are equal? Sine 60 is root 3 over 2, and cos 30 is root 3 over 2. Okay, we're going to come back to that later. All right, 30 and 60, those are complementary numbers. What are complementary numbers? Add up to 90. Okay, we're going to get back to that. I just wanted to point that out. I'm going to cancel those out. Okay, they are equal, so we can cancel it out. And we have 1 term over 1 term. Remember, that's the only time you're allowed to cancel out. Okay, if you have 1 term over 1 term. So I'm allowed to do that. So I'm canceling them out. What do I have at the top here? Root 3, and at the bottom I have a quarter. Yes, a half times a half is 1 over 4. Now, I suppose you don't have to show this step because it's quite easy, but if you had to do that, obviously remember without the use of a calculator, you would tip in times. 1 over 4, if you tip it, becomes 4 over 1. So the answer is 4 root 3. But you could, because this is a very simple one to do, I think it would be fine if you just went straight from that to the answer. And guys, if you really want to spend time and actually type that in, say you have some time after you're done writing,
Type that in and see if it gets you to 4√3. All right, it should. The calculator will give you the answer, but obviously you have to show all of that in between working. But you can actually check it. Okay, if you type that whole thing in at the top. Any questions on number 3? Number 4. We had sine of 210 degrees times cos of 180 times cos squared 45 over 1 plus tan squared. I definitely had these answers. I remember looking at this one yesterday, but I can't find it now. Okay, this one is a bit different, all right, but for sine 210 is 180 plus 30. 180 plus is in the third quadrant. What is sine in the third quadrant? Negative. So that is definitely going to give us negative sine 30. Now guys, for cos 180, the ones that are multiples of 90, all right, so 0, 90, 180, 270, 360, those you can, I don't know if you remember last year, they drew like a triangle that doesn't actually exist. And they said you must kind of remember that. You don't have to draw that, okay? For these ones, you can actually just type it into the calculator. We won't know. So you can do that. Or what I always tell my classes is to think of the graphs. Remember, we've done trig graphs already. So if you think of the graph of cos x, the cos graph, because you are supposed to do it without a calculator, but for these ones, for 0, 90, 180, 270, and 360, you don't have to show any proof, all right? Not like with 30, 60, and 45. So that's why I'm saying, if you are using the calculator, there's no way for us to know that, all right? Because you don't have to show any kind of diagram or anything for that. But guys, can we remember what a cos graph looks like? It starts at 1, right? At 0. Then at 90, it goes onto the axis. So at 90, it's, sorry, 0 is 1, 90 is 0, 180 is negative 1. Okay, so cos 180 is going to be negative 1. Or like I said, use a calculator. I'm not going to know. I mean, I will know because you probably will do it. But, but there you go. You won't be penalized for that. Please just show that value. All right, like I said already, please show me that cos 180 is negative 1. Doesn't actually matter how you find that one. Right, the only angles that you have to show proof of are the 3 special angles, 30, 60, and 45. Okay, cos squared 45, we can actually work that out already because we don't have to reduce that one. And we already have our triangle. Remember, you don't have to redraw them in every question. Okay, you draw them once and then you use them. So cos 45 is adjacent over hypotenuse. But now we're going to square it. Okay, but we're going to write it like this. 1 over √2 squared. Okay. At the bottom, we have 1 plus tan squared 330. Guys, it's tan squared. So do I even have to worry about whether it's positive or negative? No. I just need to know what the acute angle is going to be. All right. So 330 is the same as 360 minus 30. So this is going to become 1 plus tan squared 30. Okay, we're not worried about whether it's positive or negative. It is actually negative in the fourth quadrant, but the negative will go away when we square it. So we don't have to worry about that. Guys, here at the top, that minus and that minus are going to cancel each other out. Okay, we can fill those values in. What is sine 30? I cancel out the minuses, right? Sine 30 is a half. We're using the 30-degree triangle at the top. But guys, that's the easiest one to actually just remember. Okay, sine 30 is always a half. And then I'm left with this. Now, what is 1 squared? 1, what's √2 squared? 2. So this is just going to become a half as well. Over 1 plus, now I must find tan 30 and then square it. So we go up to our triangle. Tan is opposite over adjacent. So 1 over √3 and it's tan squared. So we're going to have to square that. So we're going to have 1 over √3 squared Okay, half times a half is a quarter. Hey, that's what we have at the top. At the bottom, we have 1 plus a third. Sorry. Right, because 1 squared is 1 and root 3 squared is 3. Now, what is 1 plus a third? Can you do that in your head? It's 4 over 3, hey? That's again something that if you type that into the calculator, we're not going to know. But yeah, I think most of you are able to do that in your head. And now we need to tip in times. So we're going to have a quarter times 4 over 3. I now have to tip. It's going to become 3 over 4. What is my answer? 3 over 16. So you multiply your numerators and then you multiply your denominators. Okay, how are you feeling about these questions, guys? They're not too bad. Hey, you just need to follow the steps. Remember your quadrants, remember your triangles, and then, yeah, show some working. Okay, we're going to talk about co-ratios. That is the new heading, co-ratios, which is short for complementary ratios. Spoiler alert, I have kind of given you a spoiler already. Co-ratios. Yes. What do you mean? Oh, well, this section, this is the last stuff in reduction formula, but we still have to do trig equations after Monday's test. Yes. Yeah. No, because marks are due, unfortunately. Yeah, but it's fine. It's just an extension of what you've done so far. Not really weird. Okay, let's go. Co-ratios. Are we listening? Are we ready? Okay, guys, co-ratios are finally, now we are doing the ones with 90 and 270. So co-ratios are reduction formula for 90 degrees and 270 degrees. Now guys, the nice thing about co-ratios is that they only affect sine and cos. We're not going to work with tan with these at all. All right, and I did kind of tell you yesterday what happens, but we're just going to summarize it now. We already looked at sine, was it sine 60? Right, we saw that that was root 3 over 2. That's just from the example that we marked earlier. All right, and then we saw that cos 30 was actually also root 3 over 2. Right, do we remember that? I pointed that out in the previous example. So what we need to notice here is that sine 60 is equal to cos 30. Right, we've seen that, we've worked with that before. We can do some other values. If we work with sine of 30 degrees, we all know by now that that is a half. But cos 60, if you just want to type that into the calculator quickly, or if we can just go back to our triangle quickly, I'm just going to jump back to this page. Cos 60, we're looking at 60 degrees. Cos is adjacent over hypotenuse. All right, so cos 60 is actually also a half. Right, those two are the same value, so therefore they are equal to each other. Sine 30 is equal to cos 60. All right, we're going to look at some other values quickly, ones that we can't find using our triangles. Let me just get my calculator. Now we are actually going to use the calculator for these ones. Let's do sine of 20. All right, we don't have a special triangle for 20, so we're going to have to use our calculator for this one. Sine of 20 is 0.342. All right, I'm just going to round to 3 decimals. 0.342. And then if we check cos 70, what do we notice? How did I know to check for cos 70? Because 20 and 70 will add up to 90. Okay, did we notice that here 60 and 30 add up to 90? 30 and 60 add up to 90, so they're equal to each other. 20 and 70 add up to 90, so cos 70, there we get the same answer. All right, 0.342 as well. All right, so sine of 20, oh, I forgot my therefore. Let me just fix that quickly. Therefore, sine of 20 is equal to cos of 70. Okay, I'll do one last one just for the sake of symmetry, I suppose. Let's do sine of 15. Okay, again, we don't have a special triangle for 15, so I'm just going to type it in. Sine 15 is equal to, oh, we don't like that, 0.259. I'm going to round to 3 decimals there. Now, guys, what number must I add to 15 to get 90? 75. So let's see if cos 75 is equal to the same value. Cos 75, there we go, it is equal to the same number, 0.259. So therefore, sine of 15 is equal to cos of 75. Okay, so I'm just gonna say it in words, what we've noticed, and then we're gonna write like a general formula down, not with values, but with thetas and so on. So we're seeing that sine of an angle will give you the same answer as cos of the complement of that angle. Have you guys heard that terminology before, the complement? All right, we worked with supplementary angles a lot when we did geometry. This is now complementary angles, right? Angles that add up to 90. So sine of an angle is equal to cos of the complement of that angle, 90 minus that angle, right? Sine of 60 is equal to cos of 90 minus 60. Yes? Sine of 30 is equal to cos of 90 minus 30. Let's write that in, actually, that's useful. This is cos of 90 minus 60. Right, sine of 30 is equal to cos of 90 minus 30. Right, we agree that 60 is 90 minus 30. Okay. Sine of 20 is equal to cos of 90 minus 20. So that's 70. Okay. Last one here, sine of 15 is equal to cos of 90 minus 15. Okay, so as a general rule, therefore, sine theta is equal to cos of 90 minus theta. See if that correlates to what we just wrote down in blue at the top ones. So if we're saying sine 60, then 60 is your theta, right? And that is equal to cos of 90 minus 60, 90 minus theta. But guys, obviously we can swap it around. Hey, I can start with my 90 minus, which is what's going to happen in reduction formula questions. You're going to have a 90 minus theta or 90 plus theta. Okay, and the same thing happens with 270s as well. We'll see now. So we can swap it around. We can say that cos of 90 minus theta will be equal to sine theta. Right, I took that first line and I literally just swapped the two sides around. Okay, and that is what we're going to be doing when we are working with reduction formula, guys. Whenever you see a 90 minus or a 90 plus or 270 minus, 270 plus, if it was a sine, you're going to have to change it to a cos. If it was a cos, you're going to have to change it to a sine. All right, I'm going to write some other things here. We can also say that sine of 90 minus theta. So this is a different example now. All right, you see sine 90 minus. As soon as you see that 90, you need to think, I must change sine to cos. Okay, that's why I've said let's avoid the 90s and the 270s because it's a bit more complicated. All right, if it's a 180 minus or 180 plus, we don't change sine to cos. All right, with the co-ratios, we do have to change them. So sine of 90 minus is going to change to cos of theta. Now, guys, something about all of these values. Yes. Yes. Something about these brackets that we've looked at now. 90 minus theta. Which quadrant is this in? 90 minus an acute angle is in the first quadrant. Hey, so we've actually only looked at quadrant 1 values. If you look at all of these numerical angles that we looked at, all of them are acute angles. They're all in the first quadrant. All right. We actually still have to do our normal reduction formula thing where we look at our bracket, we figure out which quadrant is this in, then the answer must take that sign. All right, so I'm just going to add it here. If you have sine of 90 plus theta, is that still in the first quadrant? 90 degrees plus an acute angle. That's actually going to be in the second quadrant, right? So we still need to do that whole thing. Whenever we're working with reduction formula, we first figure out which quadrant it's in. Okay, what is sine in the second quadrant? Positive. But it's going to become positive cos theta. Okay, so we're not only looking at the sine, we also have to remember if it's 90, I must change sine to cos. Okay, that's what makes it a bit more complicated. So this is going to become cos theta. No, because sine is positive in the second quadrant. So you take the sine of the original thing. So sine of an angle in the second quadrant will be equal to a positive value. But if it was the other way around, guys, if they said cos of 90 plus theta, (90 plus theta is in quadrant 2. What is cos in the second quadrant? Negative. So this answer has to be negative sine theta. Because guys, if I type into the calculator cos of 150, right, it's going to give me a negative answer. If I take cos of any angle in the second quadrant, my answer will always be negative. Okay, so even though I'm changing it to a sine, it still has to be negative. All right, because cos in that quadrant will be negative. Let's look at some with 270s. If we have sine of 270 minus theta, we know where 270 is, minus theta. Let's do a little thing here. All right, 270 is over here. Okay, and then we minus theta from it. That's going to end up in the third quadrant, right? 270 minus theta is in quadrant 3. What is sine in the third quadrant? Negative, but now because it's a 270, it needs to change to a cos. Right, so 90 and 270 Guys, sine must always change to cos. Tan does have a correlation, but it's not in the syllabus. All right, so for tan, you will never be able to use 90 or 270. All right, for tan, you can only use 180 or 360. We're going to do some numerical examples quickly so that you can see, because we've worked with the variables now, but let's just work with the numerical ones. If we are asked to find the value of the following without a calculator, the question there is sine 240. All right, now guys, we could obviously use 180 plus 60, right? Which is what we've been doing so far. But now we can also do 270 minus 30. Okay, so let's do the normal way, the way that we would have done it in the past. We would have said that this is 180 plus 60, right? 180 plus is in the third quadrant. What is sine in the third quadrant? Negative sine 60. I'm not going to draw my triangle now, but you would draw it, okay? And then you would use your triangle to get your value. And the value here is going to be negative root 3 over 2. We did actually calculate sine 60 up there. All right, so negative sine 60 now. So negative root 3 over 2. And guys, does that make sense? Sine of an angle in the third quadrant has to be negative. All right, because sine is always negative in the third quadrant. Instead of doing 180 plus, you could change it to 270 minus 30. So you could do sine of 270 minus 30 degrees. But now you need to be aware that if you're doing 270, your sine is going to have to change to cos. Okay, 270 minus 30, that is still in the third quadrant. Sorry, we actually didn't write Q3 here. Let me just add that. It's the same angle, guys. It's still in the third quadrant. What is sine in the third quadrant? Negative. So I'm going to change it to negative, but now because it's 270, I have to change sine to cos. So negative cos 30. All right, and cos 30 is the same value as sine 60. So this is going to give me the same answer. If you left that sign as a sign, you would now get negative sine 30, which is negative a half, which is not the correct answer. Okay, so if you have a 270 or 90, you must always change sine to cos or the cos to sine. Okay, are there any questions on this, guys? So these kinds of questions you need to be able to do like within a reduction formula question, like the ones that we just marked, where you have a bunch of brackets. If there's a 90 or 270, you need to be able to use this concept to simplify those as well. Okay. Excuse me. Any questions, guys? It's not really a new concept, it's just like a bit of an add-on. Okay, just these types of brackets you need to be able to do. I just want to show you guys something quickly, which you did last year, I think. Say again?
How do you use all this stuff again?
Yeah, no, it is a bit of a stretch. It is 20, yeah. Yeah.
How many minutes are we given on Monday?
25. Guys, I just want to show you one last thing, please. Copy this down, please. We don't have a lot of time. It's not actually, it's just, it's an application of the stuff that we've done, just put together. It's only out of 20, you're getting 25 minutes. If cos 20 is equal to P, find the following ratios. Copy this down, please. Let's stop arguing about what's going to happen and let's make sure that we are prepared for what might happen. In terms of P, without using a calculator. Guys, you have actually done these before. You did these in grade 10. But I just want to show you how they can add in reduction formula stuff here. So it's not actually new. They're asking us to write cos of 160 in terms of P. All right, cos 20 is P, guys. That's the important thing now. Cos 20 is equal to P. Let's underline that or highlight it. That is what we're going to have to use. So if they're telling us that we need to find the following ratios in terms of P, we're first going to have to rewrite cos 160 as something with a cos 20. And then we can swap the cos 20 for the P. All right, I think you might remember doing this last year. 160 and 20, what can I do with that? Jasper?
180 minus P.
Not P, because 20 isn't P, cos 20 is P. So 160 is the same as 180 minus 20. Right? Isn't it? 180 minus 20 is 160. Okay? What quadrant is this in? 2. What is cos in the second quadrant? Negative. And we know that with reduction formula, we then change it to the acute angle, which in this case is a 20. Okay, so just check, do you guys understand what happened there? Okay, they gave us cos 20. So I'm rewriting my 160, sorry, as 180 minus 20. I need to use 20 because that's the angle that they gave me. Then I check 180 minus is in quadrant 2. Cos is negative in the second quadrant, so it becomes negative cos of the acute angle, which is 20. So far, we've only worked with x's or thetas and special angles, but it's the same thing, right? If this was a 180 minus 30, we would change it to negative cos 30. Okay, I'm just doing 20 because that's the angle that they gave me. Now, guys, if cos 20 is P, what is negative cos 20? Negative P. Here we go. Number 2, sine of negative 70. We need to write that in terms of P. Yeah. Yeah. Now, guys, remember we need to try and write this in terms of cos 20. Are we noticing that 70 and 20 add up to 90? First, let's just figure out which quadrant this is in. Negative 70, what quadrant is that? Negative 70. We start at 0 and then we go negative 70. Quadrant 4, hey? This is quadrant 4. What is sine in the fourth quadrant? Negative. But guys, so this is similar to what we did previously now, Nina. We saw that sine 20 and cos 70 are equal, right? Because they're co-ratios. So this is just slightly different. Sine 70 is going to have to be equal to cos 20. Yes, P, but we have to show that first. Sine 70 is equal to cos of 90 minus 70. No, we don't have to show that. All right, you can just change sine 70 to cos 20 straight away, but that you do need to show, please. So negative sine 70 is going to be negative cos 20, which again is negative p. Now, number 3, we just have to do number 3 quickly because this is where it gets difficult. Yes?
We have -7, so
Because I changed that. Negative 70 is in the fourth quadrant. So I took the sign of sine in the fourth quadrant. So then the minus goes away. So this is a reduction formula kind of thing. Okay, so that's why that minus is now, I've put the sign of sine in quadrant 4, and now we're just using the acute angle, not the negative angle. Okay, number 3, guys, sine of 340 degrees. Now this is important. 340, I'm going to have to rewrite as 360 minus 20. So sine 360 minus 20. Why am I using 20 all the time? Because they gave me cos 20. All right, so I need to try and get it back to 20 all the time. All right, 360 minus 20 is in quadrant 4. What is sine in the fourth quadrant? Negative sine 20. Now this is a bit problematic because they told me what cos 20 is. They didn't tell me what sine 20 is. Will it be the same thing? Is cos 30 equal to sine 30? No. So now, guys, we're actually going to have to draw a triangle. So on the side, we know that cos 20 is equal to, I'm changing p to p over 1. Why am I doing that? Well, what do we need to draw a triangle? A ratio. We need one thing over another thing. We need a side over another side. All right, so p I'm rewriting as p over 1. Now, if my angle is 20 degrees, what quadrant is it in? Okay, 20 degrees is in the first quadrant. So we're going to have a first quadrant triangle. So do you see, guys, it's the first stuff that we did that we're now combining with reduction formula, okay? We are drawing our y-axis, our x-axis, our origin. Sorry, my lines are very skew, I'm seeing now. Oops. All right, and we're putting in our 90-degree angle there. Right, so just like the triangles that we did when we started new grade 11 trig, our angle is now not just theta, right? Those first ones we said that sine of theta is equal to this over this, and then we use that to draw a triangle. Okay, now they're saying cos 20, so that angle is 20 degrees, is p over 1. What is cos again? Adjacent, so the adjacent side is p over hypotenuse, which is 1. Now, if I want to find sine 20, I can use this triangle, right? Because sine is opposite over hypotenuse, but I need my opposite side. How can I find that? Pythag. All right, so what shall we call this side? Can we call it y? Because it's the y length, hey? You can call it whatever you want. I'm just making it y. So y squared is equal to hypotenuse squared, 1 squared, minus the other side squared, p squared. That's actually the same as 1 minus p squared, right? Because 1 squared is just 1. And then what do I do to get rid of that square? I square root. So it's the square root of 1 minus p squared. Now guys, please remember we did this right at the beginning of the year. When you work with surds, you can't take separate terms out of the surds. All right, so I can't now say that this is going to be the square root of 1 minus the square root of p squared. Okay, you can't do that. You can only do that if you have one term under the square root. So this is the simplified answer for y. So this is the square root of 1 minus p squared. So negative sine 20 is negative opposite over hypotenuse. This whole third over 1. You can obviously put it over 1 if you want to, but you can also just leave that out. Any questions on that, guys? I'm going to write down a few questions that are similar to this, and I want you to practice over the weekend, all right? I'm going to post the answers on Classroom for you. So the co-ratio stuff, let me just check. For these things, you can do exercise 12. Page 151. And I will post the answer to number 1 for that. For the co-ratios questions, let me just check here. 12. So we're going to add the 2 marks together, and that's out of 50. Yes. So that the one that you handed in is actually worth more than Monday's test, because that one was out of 30. Monday's one is out of 20. Okay, guys, you can do those ones. So this exercise 12 is practicing this whole triangle thing. Exercise 14 is practicing just normal reduction formula questions, including co-ratios. And then I also gave you some identities homework ages ago that we didn't mark. So I'll put those answers up as well. Oh. What mistake did you make? Oh no, yeah.
Please, ma'am, isn't it like the rule that you only have to hand it in at 3:30? I'll be super quick. I'll be quick change. I know exactly what I need. I'll hand it at the end of the lesson, like right now. Even if I have to stay in for a second. Thank you so much.
I still need to start with Romeo and do someone else,
Bye. Thank you.